It is a great pleasure and also an honor to speak here at the ZEF. Actually, I was at the ZEF 10 years ago, but briefly only 1 year and a half. And during my time at the ZEF, I always enjoyed the public uh, lectures like this. So it's really nice to come back and to meet older friends, colleagues, and also see some new faces, new blood of ZEF. So today my talk will focus on the armed conflicts and the remote sensing. So how we can use remote sensing technique to monitor the impact of the war. So let me start my talk with this comic. So this figure shows the serious crisis that we have been facing. So if you cannot read the text here, the smallest wave actually is COVID-19. And the test that says like, be sure to wash your hands and all will be well. Apparently that's not really the case, right? So this figure is not really downplaying like the significance of climate change, biodiversity crisis. But it is comic does show the concerns of the communities about the significance of the war. So though this kind of concept of war is really feels like it's far far away, and if we look at this figure which shows you the locations of the wars worldwide, we see actually there's a lot going on, especially in the global south, like in Africa, Middle East, and so forth. And if we look at the temporal trend of the armed conflicts, we see there was an increase no matter it's the war between two states or just within one state, no matter what kind of wars, there's increasing trend in recent years. And accordingly, if we look at the publication record about the armed conflicts, we also saw like the academia is also, have more and more focus to study the armed conflicts. So, okay, now I'm going to switch a little bit to remote sensing. So, because today's talk is not just about the war, but also how we can use remote sensing technique to better understand the impacts of the war. So, during the war, it's really hard to go there, for security reasons. So that's why remote sensing data is probably one of the best approaches that allows us to collect the data. And also compared to other information like reported from the media and so forth, and the remote sensing data is relatively objective, although some people may argue that there's also some sort of disinformation of the satellite data. And then of course it can cover a large area, which allows us to get a full picture of what's going on in the conflicted area. And also going into a little bit more technical side, remote sensing data could also offer the perspective that is beyond what our eyes can see by offering different spectral parameters. And then very importantly, remote sensing data can be continuous, right? So that we can have data before, during, and after the war, which allows us to investigate the impacts of the war. And also, if we look at the existing missions, so this slide shows you the existing satellites from NASA alone. And we see there's so many satellites. And now we're actually in a golden era of doing work, remote sensing work, because we have so many data. And while I do not expect you to read every mission, but I want to highlight there is a mission called the Landsat from NASA, which provides continuous measurement for nearly half a century. The earliest data we can use from Landsat is from 1970s, which is fantastic. But of course, we also have missions from ESA, European Space Agency. For example, we have a Sentinel-1, Sentinel-2. I don't know if you can see it here, which is quite similar to Landsat actually, which complement what NASA can offer. And also, let's not forget that we also have missions from the commercial companies. Let me see if I can play this. Okay, excellent. So we also have data from the companies. They are not led by the government agencies, but from companies like Planet Labs or Maxar. So all these private companies, they have something in common, the data they provide, that this commercial data, normally they are captured by, you see, a series of satellites. So each dot is one satellite. So they're really small satellite, actually, not really big. So it can only capture a really limited area of land surface, but they have so many. So they build like a constellation, and that allows to cover, everywhere in a corner and provides nearly daily data, which is really unique because the most data you can get from NASA and ESA, it's not really possible to have like a daily observation and see really clearly a single object on Earth. Um, if you use Google Earth, you would see a lot of picture. You can see clearly the buildings and the cars. Actually, most of the data you see from Google Earth, they're offered by the private companies like Maxar and Planet Labs. Okay, so now let's move to the armed conflict stories. So in order to demonstrate how we can use satellite data, so here I will use three examples and three case studies to demonstrate how we can use the data from different agencies, different types of data to understand the impacts of the war. So the first one is the war in the Caucasus, and followed by Syrian civil war, which is another iconic conflict. And also the latest one, the Israel-Hamas war started last October. So the Caucasus region is a really unique area because it's like a crossroad connecting the north and the south and also east and the west. So when I was in the States, I have to try really hard to explain to people where Caucasus is, given that the really poor geography knowledge of Americans. But I think here I don't have to really explain where Caucasus is. But the Caucasus is a really interesting place. It is like a melting pot. But unfortunately, after the collapse of the Soviet Union in 1991, and this region has experienced several armed conflicts. And if we have to put them into different categories, there are four major armed conflicts. The Chechen Wars, which is really iconic in the 1990s. So the red dot here indicates the conflict, a single conflict events during the Chechen Wars. And actually, it was a Chechen war that helped Putin to grab the power because he was very successful in the North Caucasus to to win the war. So that's how Putin came into power actually. So Chechnya is where he started his career pretty much. And then we also have the the, I don't know if you can see the colors clearly. So a cluster of the points here, they are in the Turkish blue or cyan color. They're the Abkhazia conflicts in Georgia. And then move on to the east, we have the yellow dots, they are South Ossetia. And then let's not forget Azerbaijan and Armenia. Even nowadays, we can read the news from time to time that some conflicts between these two nations. So there was a huge conflict between these countries 2 decades ago about over the Nagorno-Karabakh, which is the region these two countries are fighting for. So here we're interested in two questions. The first one is what happened? When we started this project, we don't really know what has happened here in the Caucasus, even though we see the news, we saw the news about the wars, this and that, and then we don't have a record. So that's why we want to use remote sensing data to build a record in order to understand what has happened. And then second, we want to link what we observed from satellite data to the wars. And unfortunately, we got a grant from NASA that allows us to explore our research interest in this question. So here, the main focus is agricultural land abandonment. Please raise your hands if you have heard about this terminology. Agricultural land abandonment? How? So abandonment is like the farmers give up the use of the farm. So which often happens in a conflict area, right? Like the farmers, they might get killed, or they have to move to another place. For whatever reasons, there's like a massive land abandonment. So we started with land abandonment because we assume that the war could, cause abandonment, and that could be one indicator to show the influence of the war. But abandonment actually is not that easy to capture. So when we started this project, we did a lot of literature reviews just to check how we can measure abandonment using satellite data. But we found that actually there's a lot of limitations. So we came up with a new method in order to capture abandonment. So I will not go into the technical details of how we do that. But we have one paper published in Remote Sensing of Environment to detail the methodology. But what separates our methodology with the other methodology is we could capture the timing of abandonment. For example, if we can detect if one pixel from cellular data it was abandoned or not. If it was abandoned, which year it happened. So this is really unique because the first time we were able to capture the timing of abandonment. So we applied this methodology to the North Caucasus region because here the first investigation is to understand the impact of the Chechen wars. And so the different colors here in the blue, dark blue colors indicates the timing of abandonment, like which year it occurred. And so the pattern is quite interesting because if you overlay the map of abandonment with the conflict events, so the bigger cycle indicates more armed conflict events. And we see like the pattern somehow matches. It seems like in the places where we have more armed conflicts, then we have abandonment. But can we see that the war caused abandonment? Probably not, because they might be just coincidence, right? So if you take any land system science studies, you would know that there are so many factors can influence land use. For example, could be it happened to be these places have bad soil, the quality is not so good, or there could be the other reasons, the drought, whatsoever could influence land use here. So that's why in a following paper, we came up with a series of econometric models. So we borrowed the models from economics in order to understand what are the contributions of the wars to the observed trend. So we just try to rule out the other factors like climate, like soil quality, etc. And so here it shows us indeed the war actually impacts the abandonment that we observed. So I will not go to details again, but what we found is closer to the armed conflict events, there's a higher likelihood of abandonment. So if two farms, one is closer to the conflict events, then more likely this farm can get abandoned. And then we also found that in the places where we have more armed conflict events, then there's also higher likelihood of abandonment. You may think this is like a common sense, indeed, but it is indeed, but we were also able to quantify, okay, so what's the likelihood can be changed, when we set the other constant, we could measure the degree of the influence. So which is really fascinating. Okay, so this is what we learned from Chechnya, in the North Caucasus. But is it can this finding, be applied, to the whole Caucasus when we look at the other three wars, like Nagorno-Karabakh armed conflicts, or how about the other land systems like a forest? So in another following study, we mapped land use change for both cropland and the forest in the whole Caucasus region. So there's the whole Caucasus, and here are four countries. And it's quite interesting. Not as really surprisingly, we found a lot of cropland abandonment, as we saw earlier. But we didn't find a lot of forest change, which was a relief, but also a surprise because from literatures, they are like a political, from political science and the people from different disciplines who started the war, they said that the forests were heavily impacted, not in the Caucasus region because of war and a larger scale burning. We didn't find such evidence from satellite data. So which is really interesting. We did a field trip there and try to understand what's going on. Then we later realized, even though there's no larger scale forest clearing, but there was still considerable forest loss, which is a degradation. So there's still forest, but you have fewer trees there. So it's somehow like, partly validated what the political scientists, what they documented, but we also provide a different perspective. That is, there's no large scale clearing, but these changes there, they're mainly the loss of the single trees. Okay, which is fantastic. We get a better understanding about what's going on in satellite data. So back to the topic, influence of the wars. So here we did, again, use the econometric models. We applied our models to its individual war, and also we did the investigations for the whole areas as a whole. So the figures here shows you the influence of the again the distance to the nearest conflict and the relationship between this and the likelihood of abandonment. So the decreasing trend means further from the armed conflicts, less likely it get abandoned. So the Chechnya and the Nagorno-Karabakh are exactly, what we expect. But again, we were surprised by Abkhazia and South Ossetia because it seemed like there's no clear pattern here. So even the places that are, close to the conflict events, we still have like, low abandonment likelihood. So which is really fascinating. So although we didn't really dig into that, why is that, but we did do a lot of like literature reviews to try to understand what has happened. So here we concluded that maybe this is because the wars have different influences at the different scales. So the local events, for example, the armed conflicts, if it's really high intense fighting, like the battleground, more likely we have like more direct impacts. That is, the land can be more likely to get abandoned. But in some cases, the influence could be more regional. For example, let's see Abkhazia. So what has happened in Abkhazia is it doesn't matter how close you are to the conflict events. There's all sorts of abandonment rates anyway, because there's a massive population displacement. Even the places that are far from the conflict events, the farmers got displaced. And after the conflicts was over, the farmers they didn't return. The refugee couldn't return. So even though in a place that are far from the conflict events, the farmers got displaced. They will never be able to come back. So that's why no matter where you are, the probability of abandonment is pretty much even. So now let's move on to Syria. So Syria war, I don't think I have to spend much time to talk about it because it's been like the headline of the media outlets, since last decade. It was really stunning event, and probably the Syria war is most known for creating such large population displacement, both internally and externally. And I remember this event actually shortly after I came to the US. Then I saw the news that Germany opened the border, and then I saw so many trains, carrying refugees to Berlin, to other major cities. And so I suppose the Syria probably is the one that create unscaled, never has such big scale population displacement. And if you just look at Turkey alone, for example, it hosts nearly over 3 million refugees just in Turkey. And I'm pretty sure there's also the other refugees, millions in Jordan, Lebanon, Germany, Europe, and elsewhere, which is really stunning. And if you look at where the refugees that mainly are in Turkey, they're mainly in the southeast region, close to Syria. So the south is the Syria. So that's like a high concentration of the population there. So here we have two questions. The first one, again, we want to know what has happened in Syria. We assume there's massive land abandonment, which is understandable, right? Just as what we saw from the Caucasus. Farmers, they moved away, nobody could take care of that land anymore. So of course, there should be abandonment. And then second, we want to know what happened to other places. Okay, now we have millions of refugees living in Turkey. What kind of impacts they brought to Turkish, for example, agriculture sector in Turkey and Jordan? So that's why here we want to look into both Syria and the surrounding places. So because of time is restrained, and also we are still working on the second part. So today I will mainly focus on the first part, but happy to discuss if you have any questions about Turkey as well. And luckily, we got a grant from NASA. This is the Early Career Award, and I'm the PI of this project. Okay, so let's move on to remote sensing findings about first abandonment. So here, the green color indicates stable agriculture. Stable indicates here means there's no abandonment. And the different colors indicates abandonment. So the first impression about this figure when I got it, I was like, wow, something must be wrong. Because if you look at this area, even though there's some like a clusters and hotspots, right? We see like, abandonment occurred in 2016. The purple color indicates, but it's not like a dominating. It's not dominating at all. So the majority of agricultural land, they're still green, they're still there. There's no abandonment. I thought something must be wrong. It cannot be because we know that millions of people they left Syria. So how come we have a lot of stable cropland here? So I will explain later. Why is this? And then we also look at the recultivation. I think here is a little bit cut off. But we also look at what happened. Are these abandonment? They became always abandoned or not? But we found actually some abandoned fields they got reused later, especially in recent years. That was also a surprise to us. So let me just walk you through some hotspots so that you can have a better understanding about what's going on there. So here it shows you abandonment in a place called Palmyra. Please raise your hands if I have heard about this place. Okay, fantastic. So yeah, it used to be, and maybe it's still on the list. I'm not very sure, but it definitely was, on the UNESCO cultural heritage list. But it was pretty much completely destroyed by Daesh, ISIS in English. So, and it's quite fascinating. We found also a lot of abandonment surrounding the Palmyra in the Palmyra region, and the timing of abandonment correspond to the timing of the war, which is really interesting. And another example is in the south. So I don't know if you can see it clearly. So here, this region is in the south of the city of the Homs called Al-Khazar. And this place has really intense fighting because this place is really important. If you look at the map of Syria, so actually it's like the halfway connecting Aleppo in the north and also Damascus, the capital. So there's a highway close this area. But don't forget the neighbors. Lebanon is here. So that's why this place is really important. So that's why there was intense fighting and the different parties got involved, like a Syrian government, of course, and also the anti-government Free Syria Army. And also we have Hezbollah from Lebanon. So there's a lot of parties got involved, a lot of intense fightings, try to control this region. And you see here actually it's one airport, which is very important. So that's why we also found a lot of abandonment here, and the timing of abandonment corresponds to the timing of the war, which was in 2012 and 2013. Does abandonment last forever? Not really. And then we found a lot of recultivations in later years, especially in later years. It seems like the farmers were able to reuse this land. And based on our later research review, we found this area has become much stable in recent years. That allows the farmers to reuse that land. Okay, so this is all very useful, reminiscent data. I have been doing that for decades. I know the maps, we did accuracy assessment. So even though it was a shock to us about the low abandonment in Syria, but at least we are sure we didn't do anything wrong using our reminiscent data. So the question is, why? So that's why we decided to go to the field. We decided to interview the Syrian farmers. For obvious reasons, we cannot go to Syria because for many reasons. But the first reason, number one, is this country is still on the sanction list of US government, and we cannot come there as US researchers. So we decided to go to Turkey, given that Turkey hosts so many refugees. So that's why we decided to just interview Syrian refugees there who was engaged in farming before they left for Turkey, and or who still have like a contest in Turkey. So we did extensive field interviews there last summer. But probably it was a hell of a trip. It was the most difficult field trip I have ever organized. We have so many setbacks. First is COVID. We were not able to go there. And then earthquake. The earthquake in Syria and also in Turkey killed more than 50,000 people there. It's not about only the damage, but also, it just make it physically difficult, to drive there because of damage of the road, and also more importantly, the population, the refugees, they got redisplaced again. So the tents here you see, they are not refugee camps at all. They're just temporal tents because of earthquake, the refugees they have no place to go. So that's why we saw a lot of temporal tents like this. But nevertheless, we were able to be able to find interviewees that fulfill our need, and we did really intensive travels. So we drove 8,000 kilometers in the southeast Turkey and along the bordering area from Sanlufa, Gaziantep, Hatay, and also Adana as well. And we were able to have really good interviews, effective, in-depth interviews with more than 50 Syrian farmers. And if we look where they came from, so here its individual dots indicates where the farmers were located when they were still living in Syria. And we saw like most of the farmers come from the north, which is not surprising because the Syrian people living in the north country, they tend to go to Turkey. The people in the south, for example, Damascus, Homs, they tend to go to Lebanon or Jordan because it's closer. But the people, we interviewed, actually, the places where they came from is the majority of agricultural land. Even though in the south there are some agricultural land, but the majority of agricultural land is in the north. So we're able to draw, a conclusion from this. So what do we found? So let me use one example to demonstrate the story, try to rebuild what happened in Syria in the past years. So here, actually, this is me. So we interviewed so-called Ahmed for the privacy purpose. That's why I didn't really use his real name here. So Ahmed was a landowner and also a farmer in Syria, and he lived along the river Euphrates, pretty dry, and he owned 3 hectare land, which is really big actually when you consider like small lands in Syria. And he used the water from Euphrates to irrigate his crops, mainly cotton, wheat, and corn. They did crop rotations year by year. And life was really good actually before the war. They could get the fertilizers, the seeds, and everything they need from the government. They could sell their produces very easily. They could pump the water from the canal and connected to the river. So life was really good. So when the war started in 2011, the first few years was not too bad, but we're just getting worse and worse. So in 2015, they left. Mainly because they cannot live there any longer because the situation becomes so bad that they couldn't make money anymore. It's not because of damage of the facilities. The irrigations and the canals, they are all intact. Nothing was changed, but they don't have the energy anymore. So they switched first from electricity to fuels, and then later from fuels to unrefined fuels, and just become more costly, so they couldn't stand it anymore. So that's why they all left in 2015. However, there's always a however moment. Even though they left, but their relatives who stayed take care of the land. So that's why we didn't see a lot of land abandonment in the places where he lived, because even though they are gone, but they still have friends and family there who can take care of the land. So that explains why there's such a low abandonment rate there, and which is really fascinating because it's very different from what we expected. And this video shows you the, you know, so this video shows you here. So his son, who lives in Istanbul, sent us this footage, and his son was also able to confirm his father's story with us about what has happened. So this is the first time actually I went out to the field to do the interviews, because as a remote sensing people, I used to do with satellite data and models, But this is really fascinating that we could, gather the information from the field to help us to interpret the results from remote sensing data. But more importantly, it also point out the new research directions. So now we know, okay, there's low abandonment rate. So what should we study? So that's why we move on to this one. We move on to this question. What happened to non-abandoned land? We know that abandonment rate is low, but what happened to the non-abandoned land? So then it comes to our mind that, oh, maybe even though this land they got still cultivated, but as the farmer told us, was so difficult to get energy, it's so difficult to irrigate the land. So maybe they still use the land, but then the land became not productive anymore. So how do we measure that? Using satellite data. So that's why we came to the phenology. So here it's really difficult to measure the yield from the field using satellite data because you really need a good ground reference to calibrate your models. There's so many models to estimate yield from satellite data, but without a reliable ground reference, it's impossible to do so. So that's why we measure the different things as a surrogates. For example, the length of the growing season, and also the total, accumulated NDVI, which is as an indicator closely linked to biomass. So why we measure the length of the growing season? Because we heard from the farmers that they switched from long growing seasons crops to shorter growing season crops to cope with less water and also insecurity. For example, they switched to corn from corn to cumin. Cumin is really fast growing crop. That's why we want to see if we could capture such changes from satellite data. So, and also next, we want to again rule out the observed, trend from satellite data is not caused by something else like drought. We know that Syria often has drought, same as Turkey. That's why we also use econometric models to rule out the other factors, the influence the other factors. So what we found? Um, Interestingly, and also not surprisingly, all the phenological parameters showed a declined pattern. So this figure shows you the negative trend of the length of the growing season. So which means most of the cropland here in Syria, they have a much shorter growing season length, which is exactly what we heard in the field. And does this kind of negative trend in growing season or in biomass was caused by the war? Yes. So our models was able to confirm that. So here, no matter for the length of growing season, no matter the other phenological parameters, we found that the wars definitely negatively affect all these parameters we were able to observe from satellite data. So the Syrian project is probably the most exciting one and probably the most challenging one for us. For the Caucasus project, we didn't go there. We use remote sensing data, we use the models, but it was not possible to go there for other reasons. But we were able, to build, concrete results from this. But with Syria, I feel like our research is another level because then we have the field interviews. We could build like all the episodes, before and during the war, which is really fascinating. Okay, so next, all right, I need to provide a summary about what we learned in Syria. So we found that the abandonment rate is relatively low from in Syria, and which is really surprising in the first place. But then now later you think about it, it makes perfect sense. So why is it important? It's important because if you look at the armed conflict studies using remote sensing data, most of them they only measure abandonment as an indicator. If there's abandonment, oh great, yeah, the war impacts agriculture. If there's no abandonment, maybe it's not too bad. But here, our work in Syria show that we should not only consider abandonment and non-abandonment, we should also look into them as a whole, especially productivity. So I hope this research could, point out the new research directions for the future armed conflict studies. And even though we didn't find a lot of abandonment, but that doesn't mean that the agriculture was less affected by the war, right? So our phenological analysis suggested that agricultural land use intensity, the productivity really matters. All right, so the last part, let me see how much time I have. So I will talk about the latest research, the Hamas, Israel and Hamas war. So this one is purely driven by the personal interest. It was not funded by any funding agencies. The reason why I look into this is on October 7th, last 2023, when the war just started, when the Hamas fired rockets into Israel, I was teaching remote sensing class, intro class at Kent State with more than 30 students. So on that day, we were doing a lab that using remote sensing data to monitor burned area. And then the war just started on that day. And then I decided to change the lab from the burned mapping, in the Western US due to wildfire to Israel. We want to see if we can use satellite data to map the burned area, fired due to the rockets from Hamas. And it worked. And then later I got approached by the colleagues and the media, they asked me, hey, can you, Dr. Yin, can you, measure, what's going on in Gaza? I said, oh, sure, why not? And I was said, like, oh, I could finish this within hours because I do armed conflicts all the time using satellite data. And later, I realized actually it's not as that easy as I thought. So the reason for this is, so Gaza, it's a really small place actually. It's super tiny. And if you compare it with the Berlin, Berlin is more than 2 times as big as the Gaza Strip. But if you look at the population, definitely Berlin is not 2 times high in terms of population as Gaza. So that create really unique landscapes. So here you see the satellite data shows you the first one is Germany. This one I just randomly pick it from east of Bonn. I don't know the place of east of Bonn. It's like somewhere somewhere in some villages, and this is Gaza. And you just look at this imagery. What did you see? You see like much more, stuff here in Gaza, right? You have individual dots, individual, its dot is a tree, right? It's like, orchard tree or peach tree or whatever that is. You also see something like this. These are greenhouses. So this is very different from like agricultural land use in Germany. That just create a lot of challenges. So here, actually at the request of the media and also like NGOs, they want to know what has happened, almost daily because the war just progressed so fast, like every day is different. So they want to, understand, each day, what has been happening. And then that also poses another challenges because if you look at the Chechnya work, if you look at, also the Syria, we look at the changes year by year, right? And now we need to provide almost a daily information, which is very, very difficult. So that's why we decided to use commercial data from planning the scope, from planning labs, because they have daily observations. We cannot use the other data anymore because this public available data, later you will see some examples, it's not really possible to monitor the changes there. And here we focus on 2 agricultural land use. One is tree crops like olive, fruits. The other one is greenhouses. So why these 2? Because these 2 are the most important agricultural land use. Also, they are the majority of agricultural land use in Gaza, but they are very different. Okay, so yeah, back to the data. So this is, I doubt you can see what it is, right? You just see like, a mosaics, right? It's square here is 1 pixel. We call it 1 pixel. The minimum, unit you can see. So this is from Landsat 9, and it's a 30-meter resolution, which means 1 square is a 30 by 30 meter. Okay, you can barely see anything. Next, let's look at Sentinel-2. So this is from Sentinel-2 data. So you see it's much better, right? If you go back and forth, you can see some structures like this. So each square is a 10 by 10 meter. It's better, but still it's really difficult to tell what they are. And now let's move on to 3-meter planning scope data. So each square is a 3 by 3 meter. So it's 100 times better than Landsat, right? Landsat 30 by 30 meter. So we can see much better something. And then the same day as well, let's look at the 50 centimeter, half meter resolution data, also from planet, but from different satellites from SkySat. And now we can see. So here is somewhere in Gaza, totally ruined the landscape. You see, that's why it's really messy, because everything pretty much destroyed, apart from except this stripe, which is all chalk. So that's why we decided to use both data, 3-meter resolution at a compromise, and also 50 centimeter resolution data to map the damage of the to agriculture due to war in Gaza. So because of time limit, I'm not going to go into the details. But again, we came up with a new method that allows us to do like the real-time monitoring. So we build like a dense time series. You see here from 2022, we have a lot of observations. If there's, disturbance, due to the damage of the war, we could capture, this kind of like, sudden drops in our signal. Then we label them as damage. So this is how it looks like. So the color, the cyan color here indicates the spatial distribution of tree crops. You see, they occupy almost like more than a third of the whole territory in Gaza. So this is 1 week before the war started. So this is November. So almost 1 month after the war started, and we did see some, the red patches which indicate the damage, right? Like in the north and also here, like a belt. So what happened? If we look at the, the very high spatial resolution data, the 50 centimeter data, we see, oh, actually, this is because of the invasion of the Israel army. And so they built a new road in order to, to bring the troops into Gaza. So that's why we see a lot of, damage here. And it's the same for this area as well. So there's like a new road here. And so that's why we see that along this new road, a lot of damage here. And also quite interesting. So this one was, this figure was produced by a journalist from Al Jazeera. They came to Kent and they made a documentary film. So there, and the journalist showed me this figure. This is from their own investigation, trying to understand, okay, so now we see the damage. So what causes damage? So they found some like, tracks or marks like this. They're the bulldozer tracks. So now let's look at the damage as a whole. So this is every 10 days the damage. So you see the expansion of the damage that started in Gaza City and the North Gaza, and then it gradually expand to the south, like there are Bala, Han Yunis, and Rafah as the war progresses. And if you follow the news in the past few months, you would know that it's starting in the north and gradually spread to the south. So this is how they look like. So apparently the majority of the tree crops, they got damaged. So that's why they all become red here. And if we put them into numbers, then we can clearly see like for each district and for Gaza as a whole, how it changes along the time, the damage. So of course, not surprising, we saw like the damage starting in North Gaza and the Gaza City, and then later the other places like Rafah started later. Okay, so this is for tree crop damage mapping. And then for the greenhouses, as you see here, we saw like a lot of greenhouses. How do we do that? It's very unique because it's so small. And we decided to use artificial intelligence. So here we used the model, existing AI model from Meta AI. The Meta is the company of Facebook. So they have their own AI model. So we use their AI model in order to, do the segmentation. Segmentation means you divide the whole, imagery into different segments. Each segment indicates specific objects. So using the Meta's model, we were able to delineate its individual greenhouse. So here you see we mapped pretty much most of the greenhouses, even though there's some like errors. But overall, the model did a good job to identify individual greenhouses. So this is another example. So here are the greenhouses. And here we also some individual greenhouses. So this is how we were able to identify individual greenhouses. So now let's look at the damages. So this is before the war started, October 15th, 2024. Sorry, 2023. This is March. If we go back and forth, we see like a lot of damages. Some greenhouses completely gone. Some greenhouses like here still intact. Some greenhouses partly got damaged. So we use a machine learning approach to identify the percentage of the damage. For example, if there's completely gone, then we label them as 100% of the damage. If it's intact, then or below 10% of damage, then we label as them. We use the machine learning approach. Again, I'm not going to into details, but I'm happy to discuss artificial intelligence afterwards. Now let's put them together. So here, I don't know if you can see it clearly, but you can see many dots. Its individual dots indicate the damage to greenhouses. So here, I just put them together as one map, and then I release the map periodically to the media and the NGO. And my work was extensively covered by the media and also NGOs. So I had interviews with Michael Holmes from CNN. We had 5 minutes live on TV. Also with with BBC as well. Also 3 minutes live on TV interviews. Also, we were able to, the UN agency, the UNDP also contacted me, and they put all the maps I produced in their report to deliver the messages to the international community to inform the policymakers what has been happening in Gaza. But from this project, it's the most interesting part for me, like from scientific point of view, is it's my first time to work with the journalists and with the media outlet. So many times I produce the results, a map. I send it over, for example, to BBC, and the BBC does have verification team. It's not like they take your map and then they just publish, go with it. They do also their own verification. Another example is with Washington Post. So we had like so many emails and meetings just to discuss my results. They sent me their feedback, and then I was able to, improve my mapping based on that feedback. So which was never done before because I only worked with scholars in academia. So this is the first time I worked with journalists and media outlets as well. But I do feel like, in a crisis like armed conflicts, we do need people from different, disciplines, from different fields, no matter you are, in a government, no matter you're from university and from media. And, so this is like a joint work effort in order to, deliver timely and accurate information to inform the damage of the war. Okay, the summary. So remote sensing technique probably is the best way to, use, in order to understand the impact of the war. I hope today's lecture have convinced you that this is the direction that this is the best tool probably we can use to monitor the impacts of the war. And also, even though, I was too confident at the very beginning when the war in Gaza started, I was like, oh yeah, we can do it. It's just piece of cake. But then I realized actually we still need to develop new methods, to investigate the damage of the war. It's not possible just to implement existing approaches because every region is different. The approach worked for Africa or for Syria may not be transferred directly to Gaza, for example. We still need to push the boundary of remote sensing technique. And also, even though I keep saying that we need satellite data, but it shouldn't be the only means. We do need to collect information. For example, the field interviews we did with Syrian farmers, or like I worked with the journalists, like Al Jazeera people. They used to have a network there. They showed me the drone imagery they took, but unfortunately they stopped because their journalists got killed. So they discontinued collecting the drone footage. And also, for Gaza, it's really obvious. We know that it's what's going on, but I think it's very important. We also need to consider, for some areas like Syria, we do need to build like a causal relationship in order to understand what's going on because it's just so complicated in Syria and the climate, the drought, all these other factors. So we should also, consider to use approaches for economics, for example, to help us better understand what we saw from satellite data. Now, okay, the last is the direct and indirect impact. So for Gaza, it's direct impact. We know that, the Al Jazeera people showed me the bulldozer, track, but also a lot of indirect, impacts, which we don't really know yet. So I think this is also worth investigating in the future. So with that, I want to thank our donors, which is NASA, who funded our projects. And also I want to thank my collaborators and here and there. Without them, there's no way to carry on this project. Okay, so thank you for coming and really appreciate your participation. I'm happy to take any questions.